Dear students, good afternoon. Today we talk three-dimensional transformation or three-dimensional graphics. In the graphics today lecture, we have to discuss these topics under the 3D graphics: wireframe model, hidden line, hidden surface, elimination, Z buffer algorithm, curve fitting and curve tracing. Before 3D graphics, we are know about the 2D graphics. In the three-dimensional transformation, the method for geometric transformation and object of modeling in 3D are extended from 2D methods by including the consideration for Z coordinates. Basically, in the two-dimensional transformation, we have only two coordinate, either x or y or any two coordinate. So, we cannot find out which our object is clearly identified exact position and shape of our object. So, in the three-dimensional transformation, which we have to use the three coordinate system. Basic geometrical transformations are translation, rotation, number 1 is translation, number 2 rotation, number 3 scaling. Translation, we translate 3D point by adding translation distance Tx, Ty and Tz to the original coordinate position x, y and z. So, basically we have only 3 points, 3 coordinate point x, y, z, and that should be translate to x to Tx and y to Ty and z to Tz. So, that became x dash, the translation, or you can say transformation of x dash equal to x, the original coordinate, plus Tx, the displacement of that x coordinate. Then y dash equal to y, original coordinate of y, plus Ty, translation coordinate of the y axis. Similarly, z dash equal to z, original coordinate, plus Tz, the translation of z coordinate. So, we find out x dash, y dash, z dash, these are the translation coordinate of original x, y, z. So, this is the basically translation method. Alternatively, translation can also specified by transformation matrix in the following formula. We can find out the translation by calculating any of the coordinate system by the matrix method x dash, y dash, z dash or 1. So, these are the translation. So, matrix, any unit matrix le 1 0 0 Tx, translation of x coordinate, 0 1 0 translation of y coordinate, 0 1 0 1 Tz, translation of z coordinate, 0 0 1 for the 1. So, multiplied this matrix by the another matrix x, y, z, that is the original coordinate of our object. So, then we have to be this original coordinate with the translation of the coordinate is multiplied both matrix, and you have to be concluded x dash, y dash, z dash, these are the translation of 3D graphics. Second is scaling. So, scaling is with respect to origin. We scale, what is a scaling? Basically, we scale a 3D object with respect to the origin by setting the scaling factor Sx, Sy and Sz, which are the multiplied to the original vertex of coordinate position x, y and z. So, in the scaling we have the object's coordinate is x, y, z, and then we have to be scaled by the coordinate. Scaled means transfer, and with the bigger point, that is scaled by Sx, Sy, Sz with respect to 3 coordinate. So, that became x dash equal to x multiplied by Sx scaled coordinate of x, y dash equal to original point y of object multiplied by Sy, z dash equal to z multiplied by Sz. So, this is the scaling with respect to Sx, Sy, Sz. But original the transformation of 3D is we have to find as a x dash, y dash and z dash. So, alternatively, and this method of scaling we can apply by the matrix method. The transmission matrix is following formula similarly as a translation in the scaling also, x dash, y dash, z dash 1, and here is we have a Sx, the original coordinate of with Sx scaling, then 0, 0, 0, and the y side and the y coordinate we have to 0, and scaling of bifect is Sy 0, 0, and z coordinate is 0, 0, and scaling of z multiplied by the original coordinate of the our object is x, y, z and 1. So, we can also concluded from scaling 3D graphics of scaling by the x dash, y dash, z dash by matrix method also, either by the simple way, either you have to find it the matrix method. So, we have a different type of queries can be calculated. We have to find out the different coordinate and calculated by the translation scaling by these methods. Next one is third is coordinate axis of rotation. A 3D rotation can be specified around any line in space. The easiest rotation axis to handle are the coordinate axes in the following way. Basically, rotation we have to find when the object of our any object is, we have to rotate the position, rotate by angle. So, we need a 3D translation. When we rotate either x side, either y side, in the following in the next slide, this is our any object. First of all, we are find it the coordinate axis of rotation x, y and z. Then this object is rotate by x coordinate into y coordinate. So, now x coordinate became is y and z coordinate became is x and y coordinate became a z and x coordinate became a y. So, this is rotation of by the x, then rotation of y, and similarly we can rotate of z, and which with respect to which coordinate, which axis you can see the object, you rotate by that particular particle of that coordinate. So, x rotation, so x dash equal to x, y dash equal to y cos theta, anything of you can apply, minus z sin and angle, z coordinate equal to y sin plus z cos. So, from this you can find the rotation of 3D graphics by this formula also. This is a y, that is a x, this is a y axis rotation, z equal to z cos minus x sin, x dash equal to z sin theta, or anything we can apply, any symbol we can use here, plus x cos and y dash equal to y. So, जिस rotation ते we rotate that coordinate that is equal to that is same उस angle तो आप देख रहे हैं and z axis rotation equal to z dash equal to z, x dash equal to x cos minus y sin and y dash equal to x sin plus y cos. So, this is a z rotation of 3D graphics. So, next is wireframe model. In wireframe model, wireframing is one of the method of a geometric modeling system. A wireframe model representing shape of solid object by its characteristics line and point. They are two type of wireframe modeling, pro and con. The pro is user give the simple input to create the shape. It is a useful into developing the system, while the cons wireframe model, it does not include the information about inside and outside the boundary. Basically, wireframe model we have to create the structure of our object, not all the object, only the outer structure, that is called as wireframe model. So, in the pros we have to input create the shape. It is useful developing जदों भी कोई system develop करते हैं we create the shape, and cons it does not include the information about inside and outside boundary of the surface. Just we imagine this type of our object. Nowadays in a mechanical design, wireframe model are used defining complex and solid objects. So, this is very important whenever we have to any type of mechanical engineering or either any civil engineering or any other engineering, you have to be create the wireframe model of any object. The designer make wireframe model of a solid object first and then CAD operator reconstruct the object including detailed analysis. So, basically we have to be create first of all wireframe model of our object, then our CAD operator reconstruct that object including the detailed analyze this. In this way the solid object is created indirectly by using wireframe techniques. That this technique has some advantage as follow. So, basically if we have a wireframe model, you can clearly design or clearly our object should be defined. So, before even CAD operator we know the wireframe model, then we can be easily create the object. So, some advantages are as follow. Generally the 3-dimension solid object are complex. Wireframe model can be viewed in 1 dimension. So, this competence help of the designer. So, जदों designer कोले wireframe model होएगा, easily he or she can be design the object. Second, the solid object can be modified further. The designer can ignore and geometry inside surface, while the solid modeling designer has to give the consistent geometry for all detail. Once again, the solid object can be modified further. The designer can be ignore geometry inside surface, while in the solid modeling design has to given the consistent geometry for all the details. So, जदों design करते ने any designer तो ओदा जिहड़ा wireframe model है it change that and the object is totally changed. So, you must have a wireframe technique, wireframe of any object, then easily you have to be develop or change the things of that object. So, wireframe model require less space and very few resources from CPU, because in wireframe you have to just outer structure of our object. That is why we have to require very less space for this for any object or minimum uses of our CPU. Simple example of wireframe model, any object is specified by two tables, the vertex table and the edge table. The vertex table consists of 3-dimensional coordinate values for each vertex with reference to the origin, while edge table specify the start and end of vertex for each edge. After the appropriate calculation, we have been performed the transfer and lighting transform. Once again, simple example of wireframe model in object कोई भी object है उधर two tables होंगे, one is the vertex table and other is the edge table. In the following slide you can clearly see the 3D coordinate, the vertex into 2D coordinate screen. In native interpretation could create a wireframe representation by simply drawing straight line between screen coordinate of the appropriate vertex using the edge list. Unlike representation designed for more detailed rendering, face information is not specified, it must be calculated if required for solid rendering. So, in the vertex is x, y, z. In the vertex in the first is first, second, third, fourth, fifth and so on. In the x coordinate we have it, these are the different values of x coordinate, first of 1 1, y coordinate and z coordinate. So, these are the basically vertex table and the edge table. This is a edge table. In the edge table you have different of the points and starting point and the ending of point. So, you can be generate the object of any type of our object by starting vertex and end vertex by the edge, first edge, second edge, third edge, 4, 5th, 6th, 7, 8th, 9, 10, 11, 12 and this are the vertex, the coordinate of the that particularly object. So, method for creating 3D wireframe. The extension is technique for creating 3D wireframe model by copying of 2D profile and extending it to depth defined by the operator. The result is 3D wireframe of profile. Second is the rotation produce wireframe model by rotating a cross section or profile of the part about an axis. It is a similar extension except it swept about an axis. Third, extension with the scale technique consists of defining depth with the scale technique consists of defining the depth along with the facility of enlarging the scale uniformly. Fourth one, using the primitive shapes to build the model. So, use of wireframe model, viewing the model from any desired point. This can be obtained by changing line of sight to produce standard orthographics and auxiliary view of the orthographics view are created by changing the line of sight so that it perpendicular to the front, top, profile, face of the model for creating from the view elevation. कोई भी ऐसी view जड़ा भी देख रहे हैं top view of our plan or object and the side view respectively. So, ਅਸੀਂ ਉਸ model ਉਸ object ਨੂੰ ਕਿਸੇ ਵੀ front view ਤੋਂ elevation देख लो ਜਾਂ top view plan ਜਾਂ side view. After the orthographics view are created, they must be edited or to remove the extensions, lines, add hidden and center line of trying conform with the standards. To produce exploded and the perspective view more easily, to analyze distance within the structure and checking the tolerance and interference. To decrease number of prototype required, and fourth one, editing the model, some CAD system can automatically remove hidden line using command called head. So, next one is the hidden line. Next topic in the 3D graphics are hidden line. Some object which some lines or some internal shape, internal things are not clearly shown. So, how we can be set up these hidden line in the 3D graphics? We do not want to draw the surface that are hidden, because ਜਦੋਂ ਵੀ ਅਸੀਂ ਕੋਈ ਆਬਜੈਕਟ ਡਿਜ਼ਾਈਨ ਕਰ ਰਹੇ ਹਾਂ ਤਾਂ ਸਾਨੂੰ ਹਿਡਨ ਲਾਈਨ ਬਾਰੇ ਜਾਂ ਹਿਡਨ ਇੰਟਰਨਲੀ ਉਸ ਆਬਜੈਕਟ ਵਿੱਚ ਕੀ ਹੋ ਰਿਹਾ ਯੂ ਡੋਂਟ ਅੰਡਰਸਟੈਂਡ. ਇਫ ਕੁਇਕਲੀ ਕੰਪਿਊਟ ਵਿਚ ਦ ਸਰਫੇਸ ਆਰ ਹਿਡਨ, we can bypass them and draw only surface that are visible. ਜੇ ਅਸੀਂ ਉਸ ਇੰਟਰਨਲ ਪਾਰਟ ਦਾ ਜੋ ਵੀ ਇਨਸਾਈਡ ਸੋਲਿਡ ਦੇ ਵਿੱਚ ਜਾਂ ਆਬਜੈਕਟ ਦੇ ਵਿੱਚ ਇੰਟਰਨਲੀ ਦਿਖ ਰਿਹਾ ਤਾਂ ਅਸੀਂ ਉੱਪਰਲਾ ਫੇਸ ਉਹਨੂੰ ਕਲੀਨ ਕਰੀਏ ਜਾਂ ਅਰੇਜ਼ ਕਰੀਏ ਤਾਂ ਹਿਡਨਸ ਆਪਾਂ ਨੂੰ ਕਲੀਅਰ ਹੋਏਗਾ. ਫॉर एग्जांपल, if we have a solid is a 6 side cube, at most of 3 side of cube are visible at any time, so as the following. ਜਦੋਂ ਵੀ ਅਸੀਂ ਕੋਈ ਆਬਜੈਕਟ ਨੂੰ ਦੇਖਦੇ ਹਾਂ ਤਾਂ we have it at a time we can see the 3 axes, front side, left, right side and top side. So, ਕੋਈ ਵੀ ਆਬਜੈਕਟ ਆ ਉਹਨੂੰ 3 axes ਹੀ ਅਸੀਂ ਦੇਖ ਰਿਹਾ ਹੋਗਾ ਤਾਂ ਹਿਡਨ ਲਾਈਨ ਇੰਟਰਨਲੀ ਉਸ ਆਬਜੈਕਟ ਦੇ ਵਿੱਚ ਕੀ ਹੈ we can't be concluded. By the hidden line surface, when outline of an object is to be displayed, similarly to clipping a line segment against a window. So, we apply the clipping method for such type of hidden object to show. Most of surface algorithm can be applied for hidden line eliminations. So, we can apply the surface algorithm to hidden line elimination. This is the clear picture show the linear when a surface or line passes behind the surface. In the first figure you have see the line is cross the figure within the object, the line is crossed. In second figure you say line is behind the figure. So, it is clearly we can be concluded for dotted line in this shape we can see the dotted line is show that is not a that is a hidden. So, in the first figure you have to clear that line is going through the within the object in first figure. So, next topic is hidden surface removal. Viewing looking along any projector from the center of projection, for example we see one or more surface. ਜਦੋਂ ਅਸੀਂ surface ਦੇਖ ਰਹੇ ਹਾਂ ਜਾਂ hidden surface we can't be conclude, we can't be find where is the hidden surface, we have to be see whole of the object. So, that is why we see the more than one surface, one is the object, other is near to the surface also we can see, but we do not know hidden surface how we can be generated or transferred. So, from this picture we have a curve 3 one is a direction shown the projector, we have a some triangle, circle and rectangle. So, this by the projector you can see we have to pass a one light to the projector is plane. So, in this we have to see all the shapes on the projector by overlapping each other, and some of the lines or wireframe is not clearly seen in the projector. So, some are the hidden line or hidden surface of our object. So, next is elimination of or z buffer, depth buffer और Z बफर एल्गोरिथम। सो किसी भी 3D ग्राफिक्स ਦੇ ਵਿੱਚ ਜਦੋਂ ਅਸੀਂ ਕੋਈ ਲਾਈਨ ਦੀ ਐਲੀਮੀਨੇਟ ਜਾਂ ਉਹਨੂੰ ਖਤਮ ਕਰਨਾ ਤਾਂ ਵੀ ਹੈਵ ਟੂ ਬਾਈ ਦਾ how to eliminate these things by this algorithm. Either you can see it is a Z buffer algorithm or depth buffer. In Z buffer, data in the area of video editing permits one to combine 2D video elements in 3D space, permitting the virtual sets constantly passing through walls effect and complex effects like mapping of video on surfaces. An application permits one to perform post rendering texturing on objects utilizing multiple buffers like Z buffer, alpha object ID, ultraviolet UV coordinate. Any data deemed as useful to the post production process, saving time otherwise wasted in re-rendering of the video. And Z buffer data obtained Z buffer data obtained from rendering a surface from light to PBO permits the creation of shadow in a scanline renders. By projecting the Z buffer data onto the ground and affected surface below the object. This is the same process used in non-ray tracing or ray tracing modes by the free and open source 3D applications. How to apply Z buffer algorithm? Now, we are going to discuss the Z buffer algorithm. And in the first point, initialize Z buffer and frame buffer for all the buffer position. So, all the position we have to be defined first of all. For Z buffer, x coordinate comma y coordinate equal to 0 for Z buffer, and frame buffer x coordinate comma y coordinate is equal to LB background ਜਿਹੜੀ ਵੀ ਉਸ ਪ੍ਰੋਜੈਕਟ ਦਾ ਸਪੇਸ ਹੋਏਗੀ। ਸੋ ਉਸ ਨੂੰ ਡਿਫਾਈਨ ਕਰਾਂਗੇ। Second, during scan conversion for each position each polygon surface, compare depth value to previously stored value in the depth buffer for determining the visibility. So, ਜਦੋਂ ਅਸੀਂ scan conversion ਕਰਾਂਗੇ ਤਾਂ ਹਰ ਇੱਕ ਪੋਜੀਸ਼ਨ ਪੋਲੀਗਨ ਦੀ ਜੋ ਪਹਿਲਾਂ ਡੈਪਥ ਉਹਦੇ ਵਿੱਚ ਸਟੋਰ ਕੀਤੀ ਹੋਏਗੀ, stored value in the depth buffer for determining the visibility, and then calculate Z value for each positions x, y for the polygons. If Z greater than Z buffer x, y, then set. If the Z greater than Z buffer x, y, then set the Z buffer x, y equal to Z, or frame buffer x comma y equal to surface x, y. Then stop it here. I background equal to background intensity, or I surface equal to L surface equal to projected intensity. So, this way you can be see the depth or Z buffer algorithm. So, some are the positive points, some are the negative points. So, some advantage of Z buffer algorithm pros are can be implemented in hardware. So, Z buffer is easily implemented on the hardware. Easy to process, ਇਸ ਨੂੰ apply ਕਰਨਾ ਬੜਾ ਸੌਖਾ ਹੈ. You can be easily, everybody can be apply Z buffer algorithm. We have to simply define the positions of our objects. or surfaces. Third is it processes one object at a time, because in Z algorithm at a time you cannot do any two object at a time, you can be see only one surface.